This question is taken from the ENGAA 2020 Section 1 paper, and it is question 23. So we read, a car's braking system has two cylinders of an incompressible oil. Two pistons are shown, labelled X and Y, in this diagram, so X and Y. When the driver presses the brake pedal, a force is exerted on piston X. The pressure produced in the oil by this force is then transmitted such that a force acts on piston Y. The diameters are, for piston X, 4 cm and piston Y, 12 cm. The force on X is 36 newtons. X moves 5.4 cm to the right. What is the force on piston Y, and how far does it move along the cylinder? So this topic may remind you of something from GCSE, which is called hydraulics. And the first thing we should remember is that the pressure is a constant in this. So pressure is constant, which we know from definition of pressure is the force over area. So Fy over Ay is equal to Fx over Ax. So how can we get the force on piston Y? We can just rearrange this equation. And so we get Fy equals 36 newtons, that force on X, times the ratio of these two areas. So we shouldn't need to work these areas out individually because we know the diameters and we just need a ratio. So this should be 3 squared, the factor of 3 from 12 over 4. And because we have an area, so 36 times 3 squared, which is 9. And then what answer do we get for the force? 324 newtons. So the force on piston Y is 324 newtons using this constant pressure principle. So how do we get the distance moved by piston Y? What kind of principle could we use in this case? So what you should notice is that we are using an incompressible oil, which means that the density is constant for the oil. So how is this relevant? Why did I think of this? Well, when we push piston X in, then piston Y will push out, and so the same amount of mass must push out. So this mass is density times the area times the distance moved. And this should be equal if we're pushing in a certain amount of mass, should be equal to the amount of mass that's pushing out piston Y. So if we rearrange this for SY, we get 5.4 for the area, so 5.4 for the distance, of SX, and then the ratio of the area AX divided by AY in this case, so divided by a third squared. So divided by 9, we get 0.6 centimeters. So because of conservation of mass, essentially, then piston Y only moves out by this distance.